Welcome back to FASTCABLING, everyone. Today, we're diving deep into a topic that is crucial for anyone trying to set up a long-distance network: PON versus daisy-chained PoE extenders. Sounds technical? Don't worry. I'm here to make it simple, practical, and engaging. By the end of this video, you'll have a clear understanding of these two approaches and which one might be your go-to solution for reliable long-distance networking. So let's get started. So imagine this. You're tasked with maintaining stable, high-speed connections across a long stretch of equipment. So you've decided to use PoE extenders. Logical, right? But here's the catch. In a daisy-chained setup, every extender depends on the one before it. And this is exactly the challenge one of our clients faced. Now, in their case, they needed to extend their network across 4 pieces of equipment, spaced about 100 feet apart. And at the end of this chain was a network switch, independently powered, so no PoE was needed there, and the only devices draw power from the chain were the PoE extenders themselves. Sounds efficient, doesn't it? But here's where things get tricky. So the problem is, in a traditional daisy chain, if one extender gets powered off, everything downstream loses its connection, and the entire chain collapses like a row of dominoes. And add to that inherent limitation of this setup, bandwidth bottleneck, power losses along the cable, and a hard limit on how much power can be delivered. And here's the critical point. You cannot repeat power, only data. This means if you're using a typical PoE setup, you're bound by the capacity of your PoE source. And in many cases, speed is capped at 100 megabit per second, far from the ideal for modern network. And don't even get me started on the power draw. PoE extenders consume power to keep themselves running, and poor quality cables can worsen the problem by increasing resistance. So it's a lot to handle, right? And now let's talk solutions. We offered our client 2 ways to tackle this. The first is an improved version of their existing setup by using the dual output PoE extender. Now these extenders solve many of the headache of traditional daisy chain while keeping things simple and cost efficient. Now with a dual output port, you can split the network path and one port continues the chain while the other power or send data to our local device. Now these extenders are built for reliability, featuring gigabit speed, IEEE 802.3 BT standard compatibility, up to 60 watts output power per port, and a rugged IP67 waterproof housing and automatic PoE detection. Plus, they eliminate the need for extra AC outlets, and they're powered directly through the Ethernet cable, making the installation a breeze. So let's break down the solution. So at the central port, we have our high-power PoE switch. I connected it through a 100 meters Ethernet cable to the first outdoor extender. Now this has dual port, so one of them is going to send data for the first WebSmart PoE switch, and the other port is going directly to power our second extender. As you can see, all the indicator lights are on, and it's going to connect to the second WebSmart PoE switch to add more devices. And then we have another port going to power up our third extender. Now this is our last extender, so I connected 2 PoE switches to each port. So this solution involves 3 dual output PoE extenders spaced 100 feet apart, and each one passes power and data to the next while ensuring any connected devices stay powered. Sounds perfect, right? Well, almost. The process It's straightforward to set up, relatively affordable, and doesn't require significant changes to their existing infrastructure. But the cons is still not a perfect solution for long-term stability. Now, if one extender fails or needs to be turned off, it disrupts the chain. And while using high-power PoE and pure copper cable can help with power delivery and signal quality, you're still managing a linear, somewhat fragile system. So that brings us to the second solution. And here enter the world of passive optical networks, or PON. If you're serious about reliability and scalability, this is where fiber optics shine. PON replaces the daisy chain with a star topology, where each device connects back to a central point independently. And here's how it works. At the core of a PON setup is an optical line terminal, OLT, and this device splits the fiber connection into multiple paths using optical splitters. And each path connects to an optical network terminal, ONT, which converts the fiber signal back to Ethernet. And with this setup, every node is independent, and you can even add up to 16 devices without losing power or bandwidth. So let's break down our solution. Here we have our OLT placing at a central point. And I'm going to use this fiber optic cable, string 1, to connect to the PON port. Here we go. And let's connect our fiber optic cable to our splitter. Now this splitter is a passive device. That means it does not require any power supply. So it's super safe. And let's match our fiber string. We're using string 1 here and plug it into the input port. This is a 2-in, 16-out splitter, and it's outdoor splitter. And now I'm going to go ahead and plug in 2 fiber optic cable here, since we're connecting to 2 ONU. And let's follow the 2 fiber optic cable. Now, first one here is our Wi-Fi ONU. That means it can distribute Wi-Fi signal and send data at the same time. So let's connect our fiber optic cable to the PON port of our ONU here. And then I'm using this short patch cord to send data to a WebSmart PoE switch here, so we can add more devices. And follow our second fiber optic cable. It is connecting to our outdoor ONU. And again, we're going to use this short patch cord to connect it to a WebSmart PoE switch. So this solution is pretty simple and also very efficient. And now let's compare the 2 solutions. Dual output PoE extenders are a practical, budget-friendly option for smaller networks, but they still have a single point of failure and limitations in power and speed. And PON, on the other hand, is virtually future-proof. It delivers gigabit speed, node independence, and unmatched scalability. However, it requires a higher upfront investment in fiber optic equipments and installations. So, which should you choose? If you're working with a smaller network and need a quick, cost-effective fix, dual output PoE extenders may be your best bet. But if you're planning for the long haul and need a robust, scalable network, PON is the way to go. And both solutions have their place in networking, and it's all about matching the solution to your specific needs. And I hope this breakdown has helped clear things up. And before you go, please don't forget to like, subscribe, and hit the notification bell for more deep dives into the world of technology. And until next time, stay connected.